All right, well, we're going to actually watch this video quick, but I'm like, the digestive system is split into two groups of organs. The first group of organs is known as the alimentary canal, also known as the gastrointestinal tract or the GI tract. Usually I refer to it as GI tract, it's easier to say, which means gastrointestinal. What does gastro mean? The stomach. So gastrointestinal means, the word itself means stomach and intestine. However, it does include the mouth, the pharynx, the esophagus, and stuff before that as well. So it's kind of misconceiving based on its name. It includes the entire tube that, the entire pathway that food follows throughout the entire system. So it includes all of those. So mouth to anus. It digests the food. It absorbs the food. It's got the mouth, the pharynx, esophagus, stomach, small intestine, large intestine. The other group of organs, and I'll go back and watch that video, are the accessory digestive organs. Your teeth, your tongue, your gallbladder, and all the various digestive glands. Salivary glands, the liver's not really a gland. Yes, kind of, it secretes stuff. But, and the pancreas. They all aid in digestion by helping break the food down. So they help in breaking the food down. They help, with the food that's going to be in that gastrointestinal tract. So it's kind of the actual tract itself and all the accessory organs. This is a nice little review of all the organs in the digestive system. Although you've all taken fundamentals, so you should all have some basic, recollection of the different organs in the digestive tract.
The primary functions of the digestive system are the breakdown of food, called digestion, and absorption of nutrients. Digestion begins in the mouth, where the teeth break food into smaller particles during mastication. Salivary glands, located near the oral cavity, secrete saliva, which begins chemical digestion and keeps the food moist. As food is swallowed, the soft palate blocks the upper pharynx to prevent food from entering the nasal cavity, and multiple voluntary muscles in the face, neck, and tongue contract, pushing food particles through the pharynx. The food passes over the epiglottis, which prevents food entry into the respiratory system, and then into the esophagus, which connects the pharynx to the stomach. The one-way movement of the food mass, now called a bolus, is controlled by wave-like involuntary muscle contractions. This movement is known as peristalsis. The bolus now enters the stomach. Folds in the stomach wall, called rugae, allow for expansion as the stomach fills. Stomach cells secrete hydrochloric acid, pepsinogen, and various regulatory hormones that chemically digest the bolus. Muscular contractions in the stomach churn its contents to further break down the bolus and mix it with stomach secretions to form a thick liquid called chyme. Chyme exits the stomach through the pyloric sphincter and enters the small intestine, the major site of nutrient absorption. The small intestine consists of three parts: the duodenum, jejunum, and ileum. Bile from the liver and digestive enzymes from the pancreas empty into the duodenum to aid in digestion. Absorbed nutrients pass from the lumen of the small intestine into blood and lymph. Chyme not absorbed in the small intestine enters the large intestine. As it passes through the cecum and ascending, transverse, descending, and sigmoid colon, water and salts are absorbed and chyme is converted into feces. The rectum stores feces until nervous stimulation initiates the defecation reflex, resulting in elimination through the anal canal.
So we're going to go through all that in a lot more detail. But that's a nice basic, if you're a little reminder of the different organs that all play a part in the digestive system itself. It doesn't take up my entire screen. I don't know why. I'm not going to worry about it. All right, the digestive processes. So there are 6 activities that happen in the actual digestive process itself. And they are, different colors all along. My little picture over there. The very first one happens at the top. ingestion. This is the actual act of bringing food into the mouth. Like, we have to bring food into the digestive tract. Usually, you know, little part with ingestion, you're going to have some mechanical breakdown. We'll talk more about that things happening inside the mouth. The second part, green over on the right-hand side, is the propulsion. This is the actual moving of food through the digestive tract. So it could include the swallowing, which we'll probably get to today, and the peristalsis, moving the actual food itself through the digestive tract. We have mechanical breakdown, which happens in a couple different places throughout the digestive system. Mechanical breakdown just means the actual act of physically making that piece of food into smaller pieces. So a lot of it happens up in the mouth. It also happens in the stomach as the stomach itself churns. It helps break apart the food even more. That's a mechanical breakdown. We have digestion. This is the actual act of taking large particles of food and making them into their most basic form. We're taking proteins and we're going to turn them into what? Amino acids. And like we're taking and breaking everything down to the simplest form so we can absorb it. That's the next part. As we need to now absorb all of these small molecules into our bloodstream or into our lymphatic vessels. And then we've got the last part is the defecation, removing any of the waste products that weren't able to get used. Now, in the digestive tract, we do have a membrane that surrounds the abdominal cavity, known as the peritoneum. Some of this will be a nice little review from lab this week. We have the visceral peritoneum and the parietal peritoneum. The visceral covers most, not every single digestive organ. And we have the parietal peritoneum that lines that wall. And the cavity is just that space in between. It's got a fluid inside there. It allows, the organs themselves to shift around a little bit if necessary. They're not going to go flopping all around, but they can shift around a little bit if necessary. The mesentery, if you remember, this is what anchors onto those, the big long intestines that we saw in the cadaver, and we saw it in, on different models. It plays a nice area for blood vessels to go through, for your lymphatic system, for your nerves, so that it can control your digestive tract. It helps hold those organs, hold that intestine in place, and it stores fat. That's what kind of gives it most of that yellowish appearance. Now, there are some organs of the digestive system, or some parts of organs of the digestive system, that are known as retroperitoneal organs. Which means they're not technically in the peritoneal cavity. They're still digestive organs. They just go outside of it. The duodenum is actually is one. The duodenum, that very first part of the small intestine, actually goes outside of the peritoneal cavity, and then it comes back when it becomes the jejunum. All the rest of them are known as intraperitoneal. What does intra mean? Yeah, within. So it's inside of that peritoneum itself. So there are some parts of organs themselves that lie outside of the peritoneal cavity. Now, there are 4 basic layers in the alimentary canal, or the GI tract. We learned them in lab. We saw it. We looked at a cross-section of the esophagus. These are the 4 basic layers as you go through in the entire GI tract. There are some differences as you go through different parts of the GI tract, but there are the 4 basic layers. Starting from the inside and out, we're going to look at the mucosa, the submucosa, which underneath it, the muscularis externa, and the serosa. Good picture to know. Good picture to know. The mucosa layer, again, starting from the inside, so this lines the lumen. This lines the hole, the empty space, unless there's food in it, in the digestive tract. It has several different functions depending on where it is in the digestive tract. It could perform one of them. It could perform all 3 of them. Some of the things it can do, it can secrete mucus, depending if it's got the cells, different digestive enzymes, different hormones. It could help a little bit in absorbing end products of digestion. It can also protect against infectious diseases. Like there's different cells in there that are going to protect, bacteria from getting across and other types of infectious diseases. So there's, it could have one, it could do all 3 of those different types of functions. Now, the mucosa itself is made up of 3 sublayers. So there are 3 layers in that one layer. There's an epithelial layer, a layer called the lamina propria, and a muscularis mucosa layer. The first epithelial layer, still of the mucosa layer, is made of simple columnar epithelium and it has most of it, depending where you're on the digestive tract, most of the simple columnar epithelium also has mucus secreting cells. Do you remember what those are called? Goblet cells. Yeah. So there's lots of goblet cells in most of the digestive tract, making lots and lots of mucus. It protects the digestive organs from various enzymes, so we don't digest ourselves. And it also eases the food passage. It's got mucus. It kind of allows food to slide right through that digestive tract. The epithelial lining may also secrete various enzymes and hormones, especially when we get into the stomach and the small intestine, where lots of hormones and enzymes are secreted for breaking down a food. The lamina propria is made of loose areolar connective tissue. Now, do you remember way back when? What does areolar tissue look like? No? A little bit. Because it's got all those little stringy things all over. There's also capillaries, so that we've got blood supply, we've got nutrients, we've got oxygen. There's some lymphoid follicles that help defend against any microorganisms that might, try to get into the actual digestive tract itself. And then there's the muscularis mucosa layer. It is made of smooth muscle. One of the other layers, as we go back to the 4 layers, there is a muscularis external layer. I don't care about that one. There is a muscularis mucosa layer found in the mucosa layer. Again, it's made up of muscles and it's in the mucosa layer. It, just allows anything that's in the mucosa itself, to move a little bit. Sometimes if you've got various glands, making whatever secretion it is, sometimes you need a little bit of smooth muscle to move, just secrete those, whatever it is, hormones or enzymes. All right, underneath the mucosa layer, now we're back to our 4 layers. We have the submucosa, also made up of an areolar connective tissue. You're going to find your blood, lymphatic vessels, lymphoid follicles, and you're also going to find where the nervous system now goes into the actual, one of the places that the nervous tissue can control in the digestive tract. You have the submucosal nerve plexus. We'll talk more about that in a couple slides. Underneath the submucosa, we don't talk a lot about that, you have the muscularis externa. There are 2 layers. We saw that in lab. There's an inner circle of muscle and there's an outer circle of muscle. The inner is circular and it goes literally a circle. The outer is a longitudinal. It goes lengthwise with the digestive tract itself. They rotate back and forth with their contractions and allows for segmentation and peristalsis. This is what squeezes the food and it helps move it along or helps break it up in the digestive tract. There are some areas along the digestive tract where you have a really thick circular layer. We call those sphincters, and they can tighten and hold on it so that food doesn't cross or go backwards. And then we have the serosa layer on the far outside, also made up of an areolar connective tissue in most places in the digestive tract. If you're up in the esophagus, it has more of a fibrous type of tissue. Again, it's out of the peritoneal cavity, and so we call it a fibrous adventitia up in the esophagus. All right, nerve system, like the nervous system itself controls the nervous system. There are 2 different nerve supplies for the digestive tract. One is that submucosal nerve plexus. Back to my submucosal nerve plexus. We find it obviously in the submucosa. It controls the mucosa layer, where you find most of your glands, most of the cells that are secreting various things. So it's those particular nerves that are going to control most of the secretions that are coming from the mucosa layer. Then you have the enteric nerve plexus. What does MY mean? Sometimes it has the O after it, not always. Anything muscles. And so it's controlling the actual muscle layer of the digestive tract. This allows food to move through. This is the nerve plexus that says we need to move food from point A to point B and controls the peristalsis to eventually move all that food through. Now we're going to start looking at all the anatomy, a lot of anatomy today. Just fine, just review some of the lab stuff. We're going to add more onto it though, of course. Starting at the top, and we're going to work our way as far as we can get, different parts of the digestive system. So starting with the top, the mouth, also known as the oral cavity, also known as the buccal cavity. It's bounded on the different sides by lips, cheeks, palate, and tongue. Their main goal, is to help keep the food in and keep it within the teeth itself. The oral orifice means the hole at the front when you open your mouth. It's the anterior opening. It's the fancy way of saying the oral orifice. Inside of our mouth, it is lined with stratified squamous epithelium. Why? Lots and lots of abrasion. Not only abrasion, super hot food, super cold food, super acidic foods. And I'm like, so you need some type of epithelial tissue that you can lose a few layers. You need something to kind of withstand all of that abrasion. So on the sides of our mouth, we've got, or in the front, and I'm like, we've got our lips and our cheeks. I erased off the first thing. You don't need to know that, yes, they also contain the orbicularis, oris, and buccal muscles. I think I tested on those way long ago. But different parts with the lips and the cheeks. First, we have an area called the vestibule. Now, do you remember what the word vestibule means? Yeah, the front area. So we're talking, this is the part, if I could take my fingers and I can run it in, between my lips and my teeth. The front area. So it's behind the lips, but in front of the teeth. That's the vestibule. So it's internal to the lips and cheeks, but external to the teeth and gums. So it's that space in there, underneath the lips and the cheeks, but in front of the teeth. The oral cavity proper then is all that space behind the teeth. Now, what attaches each of your lips to your gums is something known as the labial frenulum. Here's your labial frenulum. If you pulled your tongue or your lip all the way out, you'll be able to see that little labial frenulum, and you got one up on the top too. Other parts, although I'm like, you can identify these lab-wise. You have the hard palate and you have the soft palate. The hard palate, this is at the front, the top of your mouth, because what bone is there? The palatine bone. So you've got the palatine bones, the palatine processes of the maxillae make almost little bumps and projections. So if you feel the roof of your mouth, is it nice and smooth? No, it's got little bumps and projections. It's slightly corrugated. It's slightly bumpy to allow to create more friction. So when we take our tongue and we smush food up there, it helps break it apart easier. Now, Mike, it's all made for a certain reason. It helps break apart that food. Some of it, the bone is rippled. Some of it, there are almost little projections in the tissue that covers it too. Behind the hard palate then is the soft palate, which eventually the uvula will hang down off of it. It's made mostly of skeletal muscle, and we'll talk about how we, can control it when it comes to swallowing. The big thing that helps, with our soft palate, it helps close off the nasopharynx during swallowing. Why is that good? Yeah, so that food goes down and not up. So you can, eat upside down or drink upside down, and it will work. Now, the problem then can become, because it closes off the nasopharynx when you're swallowing, if you're a person that's just scarfing down food, you become winded. You also can't breathe when you swallow. And so I'm like, you can't breathe when you swallow because you close off the nasopharynx. So people that eat really fast and they're swallowing and swallowing and swallowing actually become kind of winded because they don't even realize it, that they're not breathing. I'm like, it's almost like they're holding their breath. So sometimes, you got to take an extra minute there and just settle down, take a deep breath. And then, yes, at the bottom of that soft palate comes that uvula that hangs down. The tongue that we find inside of there, made up of skeletal muscle fibers. It helps in functioning. It mixes the food around. It repositions the food around. It tries to keep moving it over to where the teeth are, so you can, push on it. It can push it up against the top of that hard palate. It tries to form a bolus. Now, what do I mean by a bolus? Yeah, it's just like a ball of food. And I'm like, because anytime I talk about a bolus, because you'll see it in various other slides too, I'm like, I'm just talking about a ball of food. So it helps form this ball of food that you're going to swallow. It can help with the swallowing by moving food to the back. It can help in speech, and it can help in taste, and we'll get into taste buds in a little bit as well. We have intrinsic muscles and extrinsic muscles. Intrinsic muscles can change the shape of the tongue, whether you can curl your tongue around or not. Those are all intrinsic muscles. Extrinsic muscles help alter the tongue's position. Is it near the front of your mouth? Is it near the back of the mouth? Can you stick it out really far? Those are all extrinsic muscles. And then we have the lingual frenulum, another frenulum for attachment. It attaches the tongue to the floor of the mouth. And I'm like, if we go back here, there's that lingual frenulum. So what does ling mean? Tongue. So it's lingual frenulum. Now, on your tongue, there are 4 different types of bumps or papilla. So 4 types of bumps. The first one, the filiform, these are the whitish bumps that you don't even really see on the picture that just are scattered all over the entire tongue. And I'm like, they're the tiniest little bumps that you don't even see that are in amongst all the other bumps that you do. They're more of a whitish color. They're there. They have nothing to do with taste whatsoever. They're just there to give your tongue friction. I'm like, it helps really well when you're licking an ice cream cone. And I'm like, you can get all that ice cream off the ice cream cone. You're all going to want to go home now and buy an ice cream cone. You know, they have nothing to do with taste. However, scattered amongst them, you have all these other little dots. These are your fungiform papilla. These are taste buds. Now, based on the name fungiform, any guess what it looks like? It looks like a fungus or a little tiny mushroom. I don't have a cross-section of it, I don't think, on any of these, but I'm like, it doesn't matter anyways. It looks like a little tiny mushroom that sticks up a little bit farther. It's usually a more reddish color compared to more of a white, and they're scattered around the tongue. They're there for taste. In the back of the tongue, you have a V-shaped row of taste buds called your valate papilla, also known as circumvallate papilla. They also contain taste buds. Now it's these 2 taste buds, your fungiform and your circumvallate, these are kind of like your main adult taste buds. So they're your main adult taste buds, the ones that are scattered all over the tongue and the ones at the back of the tongue. Kids, infants and children, also have another taste bud that really kicks in for them. On the sides, near the back, if you see these little projections on either side, these are known as your foliate taste buds. So they're on the lateral side aspects. They contain taste buds, and they normally function in kids and infants. This is why, you know, kids will say, I hate this. And, you know, even as a kid, you probably did that too, and your parents are like, your taste buds will change. They do. And I'm like, as you start to get older, these foliate taste buds kind of slowly start to stop working and your other ones start to kick in. And I'm like, that doesn't mean that these aren't working a little bit in kids. They're just not the big taste buds in kids. They're more the ones at the side. So your taste buds do change as you get older, even if, you know, it wasn't just something your parents told you. Also on the tongue, there are some cells underneath the tongue that make an enzyme. Again, anything that ends in an ACE is an enzyme. And usually, again, the name of the enzyme, it ends in ACE, and then it tells you what it does. So a lingual lipase, based on its name, it's an enzyme. What does lip mean? It means fats. This is an enzyme that will help break down fats. Some chemical digestion of fats starts in the mouth. That's not where the majority of your fat is broken down when you eat fatty foods. However, some of it starts up in there. The tongue secrete, there are cells underneath the tongue that secrete this lingual lipase to start breaking down some of that fat. Kicks in more when you get into the stomach and the small intestine. Also in your tongue, we've got several salivary glands. Lab-wise, you have to know them. Big, huge one back by the ear is your parotid. Underneath the jaw is your submandibular. Underneath the tongue, you have your sublingual. And then kind of scattered around the mouth, you have some intrinsic salivary glands. They're smaller, they're scattered throughout the oral cavity. They're there mostly just to keep your mouth moist. These other large glands, they're the ones that make the majority of the saliva, and they're the ones that really kick in if you're eating something. Now, functions of saliva. It helps cleanse the mouth. You know, like if you're just trying to, you know, clean it out a little bit, especially if you ate something. It can help dissolve some food chemicals for taste. The longer food sits in your mouth, the more taste you get out of it. Like, it's true, you know, when you just inhale food, you barely even taste it. Like, there are enzymes, there are things in saliva that can help break foods down. And so the longer they sit in there, you know, the more chemicals are going to get released and you'll taste things more. They moisten the food, you know, if you're eating crackers and stuff. They also help compact the food into a food ball, a little bolus. And there are enzymes in there that help begin the chemical breakdown of starch and enzymes. Mechanical breakdown of food is going to happen because you're going to chew and make it smaller pieces. Chemical digestion also happens. So we've got chemicals in there, I mean specifically enzymes, that can start breaking down starch. Now, what is saliva mostly made up of? Water. It is mostly made up of water. However, it is slightly acidic. It's not an acid. You know, I wouldn't say it's like way low on the pH. It is slightly acidic, though. There are electrolytes in there. What does an electrolyte mean? That's an example of one. You're even closer. It doesn't have to be. It's anything that will split into ions when you put it in a watery type solution. So some of these are positive, some of them are negative, but they were generally in like your sodium and your chloride were salt, sodium chloride, and then you put it into a watery solution, and now you have sodium ions and you have chloride ions. So you've got various ions that are in there. You've got a salivary amylase. The salivary amylase, this is an enzyme. Again, it ends in ase. Amyl, I don't think I have it on there, has to do with carbohydrates and starches. So salivary amylase starts breaking down those carbohydrates. And then you've got that lingual lipase that those cells underneath your tongue secrete that help start breaking down your fats. You've got something known as mucin in there. It's a protein. It just kind of helps lubricates the mouth in general. You've got some metabolic wastes like urea and uric acid. You have lysozyme, which is, I was going to say, it's an enzyme based on its name. It does come from the lysosomes. Its main job is to inhibit bacteria growth for tooth decay. That doesn't mean it's going to stop it altogether and you'll never get tooth decay, but it does try to inhibit some of the bacterial growth for tooth decay. You've got also have something known as defensins that protect against microorganisms. These are things that are going to go, if all of a sudden they notice something abnormal, they're the ones that are going to go recruit white blood cells to come to the mouth to fight off whatever's there. Now, you make approximately 1,500 milliliters a day of saliva. I was going to say, one of these, my water bottles, is 500, without it flattened. And so you make approximately 3 of these a day in saliva. It's a lot of spit. Mostly you've got those intrinsic glands that are all over your entire mouth that just try to help keep your mouth moist the whole day. And then you've got those extrinsic salivary glands, the parotid, the submandibular, the sublingual, that if you've got any type of food in your mouth, they can sense it. There's various chemoreceptors that all of a sudden you start making saliva. That's all parasympathetic nervous system. Generally, if you remember again, what's the parasympathetic nervous system? When does it kick in? It's rest and digest. Here's part of the digestion part. You make lots of saliva. It helps with digestion. So when your sympathetic nervous system kicks in, it inhibits salivation. Your mouth goes dry. When you're under a lot of stress, like you have to get up and give a really important speech, your mouth goes dry. That's the sympathetic nervous system. I was going to say you'd have cotton mouth. It would be harder to swallow. So I'm it wouldn't be good. It would be harder to swallow. Also in your mouth, obviously you've got teeth. Their main job to help tear and grind food for digestion to make it as small as possible. All of your primary and your permanent dentitions, aka teeth, are completely formed or should be, and you should be able to see them by the time you're age 21. You have 20 deciduous teeth that arrive somewhere between the ages of 6 and 24 months. What does it mean when you have deciduous teeth? They'll fall out. Yeah, just like a deciduous tree. It's like environmental science class. A deciduous tree is what happens to their leaves every fall. They fall off if you're a deciduous tree. Deciduous teeth means these are going to be the teeth. They're also nicknamed primary teeth. These are the teeth that are going to fall out. Somewhere between the ages of 6 and 12 is when the kids' teeth start to fall out. They fall out in the same order they came in, unless they got knocked out. And they come in, they start to fall out as your permanent teeth start to come in. Altogether, you have a total of 32 permanent teeth. The last molars are they're the ones that come in usually by the end of adolescence. Again, they usually are in by the time you're 21. Sometimes those last molars might take all the way up until the age of 25 before they finally pop through or erupt. Because they don't start to come in until sometimes the ages of 17 to 25. This is the time when they start to become problems. Has anyone in here had their wisdom teeth taken out?
No, but I have mine now.
I was gonna say, Mike, I had mine taken out too. I'm like, and it's generally high school. High school? Yeah. I was gonna say somewhere in that age. I'm like, that's usually the time when they start to become a problem. Is like when they start to come through, late high school, early college, in that particular time period. That's when they notice they start to come. They're pushing forward, they're pushing at weird angles, and they're gonna move all your other teeth, and they just remove them. Some don't even erupt. I had 5. I was like, extra smart. I had 5 that they had to remove.
My ex-husbands were so big that the dentist asked if he could keep one for us.
Really? I had 4 normal ones and 1 tiny little random one. It's an extra tooth. We go into it. I'm like, kind of your basics. I don't really care. I'm not going to ask you about the baby teeth, but I like the picture that shows, because it's a nice review from Lab 2. I'm like, the front teeth you have are your incisors. They're the flat blade-shaped teeth. Their main job is for clipping and cutting. So if you're going to eat a carrot, again, these are like the Easter Bunny teeth that stick out. Their main job, if you're going to eat a carrot and you want to cut it into 2, you're going to use those front teeth. They're for clipping and cutting in half. When you start to go back, you've got your canine teeth. They're a little more conical shaped. They're a little more pointed. Again, they look like the scary little teeth that dogs have that stick out, hence the name canine teeth. Their main job is for tearing, just like that dogs use them and animals use it. We use them too. Behind that, you're going to have your premolars or bicuspids. The bicuspid is because you have a front side and a back side. Now you start actually seeing a definite indent in the tooth itself. So you've got a front side and a back side. And on the very far back, you've got your actual molars. Now, your premolars and your molars, their main job is just for crushing. So if you wanted to crush something, if you wanted to chew on something that was really, really hard, you're probably going to put it to the back of your teeth, and they're going to crush it. Now, I'm like, if you're going to try to eat a carrot, and I'm like, you're generally not going to put it to the back of your teeth and try to eat it, because all you're going to do is, like, gnaw on it. And I'm like, it's not, their main job is not for cutting in half. They would gnaw away at the carrot, but you'd be sitting there for a while looking funny. Different parts of your teeth. The part you can see is the crown. The part you can't, that's, below the gums, is the root. The gingiva is the fancy name for gum. Your crown is covered by enamel, the white part, which is the hardest substance that you find in the human body. Now, as soon as that tooth erupts through the gums, no more enamel is put on it. So enamel-producing cells, as soon as that tooth erupts, they decay. So if you damage the enamel, too bad. That's all you got. As soon as that tooth comes through, that's all you got. That's why they always say kids, where their teeth come in later is actually better. The later the teeth come in, the stronger their enamel is going to be. Other parts. The dentin, it is kind of a bone-like structure that's underneath the enamel. Inside of there, you have an empty space called the pulp cavity where you find the pulp. That's where you've got your blood vessel, various nerves. You have the root canal. This is where it's going to anchor out. Sometimes if you've ever, as a kid, pulled your tooth out, get a little dangly thing hanging there. There you go. It's part of the root canal. Part of those nerves and, blood vessels that died off. The very, very tip of the tooth is called the apical foramen. Again, what does foramen mean? The hole. Apical just means a tip. So it's the hole at the tip of the tooth, but on the bottom side. Again, that's just the passageway, the hole for those blood vessels and nerves to go through. The tooth and some gum diseases. The official word for a cavity is a carie. So a dental caries are your dental cavities. Now, what happens with dental cavities, that enamel starts to break down. I'm like, again, we need that enamel, that really hard substance to protect our teeth. Now, how this actually happens, and I lost my pointer. Dental plaque. This is the film of sugar, bacteria, and debris that adheres to teeth shortly after you eat. You've probably all had it at some point. You've eaten something, all of a sudden you're like, my teeth feel a little furry. That little furry stuff that covers your teeth, that's your dental plaque. Now, that's usually the first indication that you probably should go brush your teeth. And again, the more sugary something is, the more furry your teeth are going to feel. That is your dental plaque. Now, the problem with it is you have bacteria that love to hang out, in this dental plaque. That bacteria, as it starts to eat away at all that sugary stuff that you just got done eating, that bacteria itself secretes an acid. What's the acid going to do? It's going to break down the enamel. And so that acid is going to start to break down that enamel, that really strong substance, and then you have other enzymes called proteolytic enzymes that help digest that organic matter. They help digest that broken down tooth. So it's like the bacteria secreting acid, the acid break down the teeth, and you have enzymes that help, absorb and digest that tooth material itself. Now, if you are drinking, yes, as we were talking, the Mountain Dews and the Cokes and things like that, that already have an acid, if you drink a sugary Coke, not only does it have acid in it, you now have sugar that's going to make plaque and bacteria that are going to secrete even more acid. It's like double acid when you drink a sugary Coke. So a Diet Coke, it's like half as bad, but it still has lots and lots of acid in it. Anytime you drink the sodas, they've got acid in them. And that can help break apart the enamel without even having bacteria. So the best prevention, daily flossing, brushing, getting rid of any of that, a lot of people, yes, as soon as they eat, they brush to try to get rid of that, furry feeling. Gingivitis, which is an inflammation of your gums. Some of that plaque, that furry stuff that you didn't brush off, because even sometimes brushing you don't get it all off. Sometimes you have some plaque that hangs along the edges. Sometimes that plaque will calcify and it will harden and it forms something known as calculus or tartar. This is the stuff. Once it calcifies, once that furry stuff that you didn't brush off calcifies, a toothbrush is not going to get it off. This is why you sit in the dental chair and they get out the scrapers. They are scraping the tartar. That's all stuff that you didn't brush off fast enough and it calcified. Eventually what can happen is that this calculus that usually hangs out around the gum line where you don't brush well enough, it can, start to get underneath the gums. The gums, to be happy and healthy, like to be right up against that nice smooth tooth. And now when you have this irregular calcified substance in between it, it starts to inflame the gums itself. It's gingivitis. Sometimes you get bacteria that's in there. Easiest thing to do, scrape it out, and your gums usually heal by themselves. All right, some review. The esophagus is part of the what, while the pancreas is considered a what when it comes to the digestive system. It is. The esophagus is part of the alimentary canal, also known as GI tract, and the pancreas is an accessory organ. Choose the answer that lists the 4 layers of the wall of the alimentary canal in the appropriate order from innermost to outermost. Yeah, it's still pink. Why does your mouth suddenly go dry when you're about to deliver a presentation to a large crowd? It is the green. It's your sympathetic activity. So when you're under stress, inhibits salivation. Most teeth are primarily composed of what? It is. Dentin is, the biggest part of the teeth. We're actually going to end right there. It's a nice little thing. Yay, you made it through the week.
Do we have a quiz next Monday?
No.